Today we're at the Northwest College of Construction in Portland, Oregon, and we've been here to conduct a workshop on high-performance walls that would meet the Oregon Department of Energy's specification for a high-performance wall system. It would have to have at least an R value for the entire wall of R20, which this wall meets. Building wrap on the outside of the building, we've actually used a special building wrap called drain wrap, which has a wrinkled surface allowing water to flow, if it were to reach this paper, behind the foam insulation and out of the building.
But this is our product called Flex Wrap. Most of you have probably seen it, but it's a butyl base instead of a bitumen base. And back there, but even here, down, that'll all self-seal on itself.
We have 1.5 inches of foam insulation outside of our building wrap. In front of our foam insulation, we actually have 1.5 inches by 1.5 inches wooden battens. These battens are here to carry the weight of our cement board siding, which will be installed over the surface of the battens. These are screwed with 5-inch long screws into the framing of the building. So these screws pass through the foam, pass through the sheathing, and into the studs that make up the structural part of this building. And that way they can handle the weight of the siding that gets applied. You'll notice if you look down at the bottom of the wall that we have ventilation strips at the bottom of the wall. That's designed so that air can come into this wall cavity from the bottom and be able to travel all the way up through and out another ventilation cavity at the top. And that air being able to move through that cavity will actually dry out any residual moisture that's left in the cavity once it's dripped out through the bottom. When the siding gets installed in this application, you would actually have from the outside, everything would look like a normal installation, siding and trim. The only indication you would ever have that there are these battens and insulation is by seeing that there is this jamb extension at the windows. From the outside, it would look like a typical house. From the inside, it would look like a typical house. It's going to perform much better in terms of saving energy. Much less heat is going to move through this wall system. And in addition to that, there's going to be much less opportunity for there to be moisture problems in this wall. Both from the outside in, it's going to be hard for rain to cause a problem with this wall, and from the inside out, high levels of humidity inside your house are not going to cause rot in this wall assembly because of the fact that this insulation is keeping the entire structure warm.